Bühne. Ich freue mich nämlich jetzt auf deine Premiere, The Complexity of Online Spaces. Herzlich willkommen und Bühne frei für Lena Mangold! Dein Applaus, dein Mikrofon, deine Präsentation, deine Claire, die natürlich erst startet. Wenn du soweit bist, ich freue mich drauf. Toi.
Hello. So, because we haven't already heard so many languages today, I thought I'd add another one. I'm doing my PhD in computational social science, and when I'm asked why, as a mathematician, I went into this field, I have two answers. I call it the expectation versus reality. So, we live in a complex world, and to understand the social phenomena, we need to push the boundaries of science and complement traditional social science with methods from maths, physics, computer science, and so on. In reality, I'm just a bit of a nerd, and I can't even decide what clothes to put on in the morning, let alone a field of academic study. So, and I have absolutely no endurance to stick with one thing, which is how I ended up in this interdisciplinary field. So today I'm going to be talking about the complexity of online social systems and what they have to do with ants. A bit of a cliffhanger for you. So to start with, we're going to scroll through my Twitter feed together. First of all, since I started my PhD, it really looks like this, for reasons of procrastination and to calm the PhD-related anxiety. But what I also often see is these kind of things. So I see that things that people post in the opinions sound strangely familiar, and I'm sure we've all thought about this. It just feels like a bit of a bubble sometimes, doesn't it? What I also sometimes see is things I don't agree with that much. So, for example, my cousin's best friend's aunt, who I follow because she posts great otter pictures, she also sometimes posts these kind of opinions that I don't agree with so much. So there's a bit of a contradiction going on there. Feels like a bubble, but also sometimes I feel like I'm exposed to things that I wouldn't normally come across if I was just living in my offline world. And this kind of summarizes a debate that's going on around a phenomenon that I'm sure most of you have heard of, namely that of echo chambers. So environments where people come across opinions that they already agree with, which get reinforced, and maybe they will kind of unlearn to find common ground with people who have different opinions from them. It turns out, just like my experience on Twitter, this kind of contradiction, people who research this topic also disagree with each other. So some people insist that echo chambers exist, and others say, actually, we're exposed to more things, more kind of opinions of other political ideas that we would see if we were only living offline. So I'm now going to introduce to you the kind of methods that I use in my research to hopefully at some point provide a little bit of insight into this big question mark. This set of methods is called complex systems, and I'm now going to do something that I was told that I shouldn't do in the science slam, which is to put an equation on the slide. But don't get too excited, because it's pretty easy. And you'll be happy to see that the ants are coming back. And just for a second, I want you to forget everything that I've been talking about social media, because I'm going to do a little detour and explain what a complex system is. So just imagine you've got some ants crawling around, not super interesting, just by themselves, maybe cute, maybe annoying because they're eating your food, but not super exciting. When it does get exciting, at least in my mind, is when they come together in big groups and they interact in certain ways and they create amazing things like this without having been told by anyone to do so. So they do this in a self-organized way. And the reason that I've got these plus signs here and the is not equal to sign is that the whole is not equal to the sum of its parts. So by looking at the individual behavior of each of these ants and kind of summing it up, you can't explain these kinds of phenomena. This is just one type of complex system. There's many, many complex systems in the real world. Another example is birds that create these incredible formations when they come together in big groups. And scientists have been coming up with lots of different methods to try and understand these kinds of systems. And it turns out that to understand them, you have to look at the system as a whole, not just at the individual parts. And what people have been doing in computational social science is to borrow some of these methods and analyze the data that we have from all these digital traces that we're leaving everywhere to understand the kind of things that happen when people talk online. So the phenomena here might be something like an echo chamber, so it's information that's diffusing in a social network, opinions that are being passed on, and so forth. And that is exactly what I'm doing in my research. So let's imagine we've got a set of Twitter users. I'm using Twitter here as a proxy, could be another type of social media platform. And let's imagine that these people are talking about a certain topic and they are retweeting each other. So every time one person retweets another, there's an interaction happening and they're kind of connected in some way. And we can draw this by drawing a line between them. So this sort of set of methods out of complex systems, it's called network. So we're looking at the conversation of Twitter users as a network. And one thing that often happens in these types of networks is that people start talking to each other within groups, so they talk lots to the other people in the same group, and less so to people in other groups. So here you can see this very nicely. You've got these two groups here, left and right. Now that in itself might not be so interesting. I'm interested in the semantic level, so opinions, topics being talked about, worldviews, and how they kind of correspond with these groups. So let's imagine the people in this set of users have they're on two different ends of a political spectrum, just as a very simple example. So let's say we've got the reds and the blues, and they're kind of very different ends of the spectrum. And let's say in this example, people within each of these groups, even though they're only talking to each other in this group, but they're talking to people of very different kind of political ideas from themselves. What if this happens? Now this very much looks like it could be something like an echo chamber. So you've got people only talking among themselves, and also only talking to people who have very similar opinions to themselves. So what I'm interested in my research is to kind of zoom out from this. When you look at it in this kind of way, it's very easy to visualize it and just to say, okay, we've clearly got these two groups here. As soon as you zoom out and you look at conversations of thousands and thousands of people retweeting each other, you need algorithms that help you to detect these kind of things. So you need algorithms that help you to detect the groups, so do these kind of groups exist? And also, if they exist, how many of them, what is the kind of structure of them, and within these groups, are people talking to each other, to other people of different kind of political ideas, or not? So that is what I'm interested in. And particularly, I want to know, does this happen differently in different types of contexts? So can we find certain topics or certain sort of sets of users or certain platforms where a conversation looks more like this? And can we find other topics where maybe a conversation looks more like this? Or maybe it's a mixture of the two, or something completely different that's way more complicated that we can't even visualize like this, where we definitely need the algorithms to tell us what's happening. Or maybe we've got something like this happening, where it starts like that, and over time you've got these kind of fragmented groups that are kind of emerging from this system. So I hope I've convinced you that echo chambers are not as sort of simple as it seems, and it turns out maybe it just depends on the context. I hope you agree with me that complex systems are beautiful and cool, and I hope that you look at ants in a different way next time. Thank you.
Und ihr seid wieder dran. Bitte genießt eure Gruppenarbeit.